we're starting off looking at some definitions of networks, okay, and we'll go through these a little piece at a time. So here's part A. So the first thing we need to know is what actually is a network. So a network is defined to be, it's made up of arcs or edges, and it's made up of vertices or nodes. So arcs and edges are the same word for the same thing, and vertices and nodes are two words for the same thing as well. Now, what does that actually mean? Well, let's have a look. We'll start with looking at what arcs and edges are. So arcs and edges are the lines that connect places or things together. So like my driveway, okay, that would be a line. It's connecting my house to the road, or the road itself is connecting different roads together, okay. So for example, here's a picture of Macaulay High, just a Google map, and we've got Macaulay in the middle, okay, there's our Macaulay that we can see there, and we've got a bunch of these roads around the outside. We've got High Street, Hutton Street, Church Street, Avenue Road, all sorts of stuff. So I could put a line along every road there, okay, and that's what I've overlaid in blue there. Those are my arcs or my edges, and those arcs or edges in this example represent a road. And so then I would just take away the map and I'm left with my network diagram. So this is a network diagram that's got edges in it. The second thing that we need are nodes or vertices. Okay, so this is where those edges meet, so where roads meet, intersection points. Okay, are good examples, and we're usually going to give that a label, A, B, C, D, E. Sometimes people will do numbers, 1, 2, 3, 4, 5, but often we'll use capital letters. So for example, here's our Macaulay map, and you can see we've got our blue arcs drawn in, and wherever the roads meet, I have put those big green dots. So those are our nodes or vertices. And when we take away it, that's what we're left with. So this is a network. In this network, we have the arcs or edges, which are all these blue lines, and we have the nodes or vertices, which are the green dots. So we've got our roads and we've got our intersection points. So that is what a network itself is. And we can label those A, B, C, D, E, F, G, H. And that is a complete network now. So reminding you, a network is a graph which contains arcs or edges, and it contains vertices or nodes. Alright, so that's what a network is. So when we come to draw diagrams, we can simplify things, and the key idea is we can draw them in lots of different ways, but it's the connections, where there's a connection between this place and that place, that's what's important. So for example, in this diagram here, these diagrams look different, okay? The middle one and the one on the right here look a little more similar. They both start with A in the top left corner, but then this middle one, it's got an arc going across the top from A to D, whereas on the right hand side it goes from A across to B, but it does still have an arc going between A and D, okay? Same with the middle one's got an arc going from D to C, and in this right hand side one there's an arc going from D to C. And if we match them all up, we'll find that there are arcs between every pair of nodes that are the same. This first diagram is a little bit different. It's got this little bridge thing here, and that literally is a bridge, or just the lines crossing over to show that it's not meeting at a point in the middle. There isn't meant to be a node in the middle there, it's just jumping over it. Equally, we could have drawn that line that goes all the way around, okay? So we can represent those diagrams in slightly different ways. So we can often simplify things. So if you've got a road map and you've got a town here, and you've got a town here, and a town over here, then instead of having the road being a squiggly line that goes like that, we could just say, look, there's a town there, and there's a road that goes between them. Okay, so just we can tidy up the diagram when we come to draw it. So now we get into the first key idea, and this is the idea of order. So every node that we have, every intersection point, remember, we want to count how many arcs or lines are going into that node. So then what we find is called the order. and we want to find out whether that is an odd number or an even number. And this is going to be useful particularly when we get to our traversability method, which is one of the 3 methods you need to do for achieved. So here's an example of a network. Okay, I've got my nodes there in green, and I've labelled them A, B, C all through F, and I've got these arcs in blue, so those are the roads connecting them together. So I'm going to start with node A, and you can see up here I've just put it in, I've coloured in yellow, coloured in red for you. So I'm starting with node A, and I'm looking how many arcs are there that go into it. And you can see there I've highlighted that one arc. Okay, so there's one arc there that goes into that node. So that means node A has an order of 1. There's only one arc going into it. And 1 is an odd number, so therefore that is an odd node. Okay, so that's node A done. Now I'm going to have a look at node B. So I've coloured that in red because that's the one I'm focusing on, and I want to know how many arcs go into that node. So I've got 1, 2, 3. You can see I've coloured in 3 arcs there, and those 3 arcs all go into node B. Okay, so that means the order will be 3. 3 is an odd number, so that means the node is an odd node. Now we've done A and B. Now we'll start again and look at node C. So I've coloured that one in red. And let's look at how many arcs go into node C. So I've got 1 arc going between B and C, 1 arc going between C and E, and 1 arc going between C and D. So there are 3 arcs that go into node C. So that means it's order 3. 3 is an odd number, so therefore it's an odd node. Now we'll have a look at D. So D's got 1, 2. It's only got 2 arcs that go into it. So 1 arc between C and D and 1 between E and D. So that means its order is 2, and 2 is an even number, so we can say that D is an even node. Let's look at node E now, and we've got an arc going between E and F, an arc between E and C, and an arc between E and D. So that means it's got 3 nodes, the order is 3, and 3 is an odd number, so E is an odd node. Last but not least, node F. We've got 1 arc going between E and F, and 1 arc going between B and F. So going into node F, there are 2 arcs that go into it. So order is 2. 2 is an even number. Oh, I made the mistake. So where it says odd here, we're going to change that to even. Alright, that's my mistake. Okay. So that's what we can do, is we can look at the order of every node in a network. The second idea that we need to look at is this idea of connectedness. So we're talking about something being connected. So there's a connection if there is a pathway between every pair of nodes. Okay, we're only going to be looking at connected graphs, so we're not dealing with more difficult ones. So for example, this is a connected network. I could go from node A to any other node. There is a pathway that I could travel to get to every single different node. Same with node C, there is a pathway that I could get to any particular node I wanted. So there is a pathway between every place, A, B, C, D, E, F, and each other. This is an example of an unconnected network, and what you'll notice there is that there isn't an arc between A and B, and that's why this network is unconnected. Okay, if there is a connection between A and B, if there was an arc there, that would make it a connected network, but at the moment it's an unconnected network. So now what I want you to do is I want you to go on to page 3 now and find exercise A, and I want you to go through and answer questions 1 through to 6. Now we haven't got much time for the learning in this topic, and so you need to finish this exercise within 1 lesson. Okay? If you get that done very quickly, then the next piece is a Merit and Excellence Challenge. So then that would be still exercise A, but going through and looking at pages 6 and 7 and answering questions 10 to 15. Okay, but again, you have to complete this. You've only got 1 lesson allocated to complete exercise A.